All right, I think we're ready to begin. Welcome to day Tuesday. I'm having a great time. Shika Razada could not be here today. My understanding is she had an injury. So instead, her update is going to be given by Roman Markovich, which I cannot see. Oh, there he is. There he is. Yeah. Cool. Oh. And there's instructions there for this. Cool.
Thank you, Lindsay. In the aeronomy part of this update, I will cover recent restructure of our division of atmospheric and geospace sciences. I'll quickly go through some recent updates in proposal preparation. I will also very quickly go through some current funding opportunities in geospace. I'll present some highlights from recent activities related to solar eclipse, and then we'll talk about career FDSS awards and also some facility-related awards. And I will then present my own update on geospace facilities and then present an update on data infrastructure. So as I said, our part of NSF, Division of Atmospheric and Geospace Sciences, recently has underwent through a restructuring. And as a result, we don't have sections anymore. So Geospace section is no longer. But fear not, here comes, rising from the ashes, Geospace cluster. And that's not just a name change. The idea for this restructuring is that we want to blur the boundaries between different parts of AGS, different programs, and work even better together. The roles of program officers have not changed much compared to last year. Shika Razada is still doing aeronomy. Mangala Sharma space weather, but she's also now current, what we call cluster coordinator for geospace. Lisa Winter, solar terrestrial, even though she's currently at NASA. Qialin Huang, magnetospheric physics, Tain Huang, data infrastructure across geospace. And myself, I'm still doing geospace facilities. But you can see there is an arrow here. What it means that geospace facilities program has been moved to the newly formed infrastructure cluster. But in other ways, I and the program still remain firmly embedded into all activities geospace. And one good way to think about it, that the program will be operating in the overlap area between infrastructure cluster, that includes one of our major facilities, NCAR, and geospace. So let me quickly go through some recent updates in our proposal and award policies and procedures guide. One important or more important updates is that there have been changes in the way bias sketches are prepared, and also they can be more than 3 pages, and bias sketches are done through this new system called ScienceCV, where basically PIs upload the information, and then they can generate their own bias sketch kind of in automatic fashion. Synergistic activities used to be part of bias sketch, but they now have been moved to another part of the proposal called senior personnel documents. Then current and pending support. I know it takes a lot of time to prepare those, and also if you're making an award in advance of that, we request an update for this current and pending. That's also will be done through this new system, Science CV. One important update is to do with mentoring plan. If before mentoring plan only applied to postdoctoral fellows, now it applies to graduate student training as well. I think that's a very good change. Too often we have proposals saying, well, graduate student will be involved, and that's it. So now you PIs would prepare actually similar mentoring plan for postdoctoral fellows and graduate students. So here is our list or depiction of our current opportunities in Geospace. GEM and CEDAR is, of course, most relevant. Currently, we have first Friday of May as a target date. Then it's sibling solicitation in GEM and SHINE. And I would like to draw your attention to the rightmost solicitation on this slide, FDSS. Many of you are well familiar with this solicitation. I would like to emphasize that this is now a standing solicitation. It's a biannual solicitation with a next deadline of March 3, 2025. And here is a list, or again, a depiction of the previous 6 recipients from the previous cohort with a competition run in 2023. It's, in my opinion, a unique and very good program. As you can see, NSF provides support for salary, benefits, and everything for up to 5 years, up to $1.5 million for new hires. So if your institution has not been selected in the past, that means that your institution is eligible now. It's time to think about the next competition in 2025. Our ONME program has contributed significantly to research and outreach activities associated with solar eclipse. And here's a map of various facilities and projects that participated. These are not only our own projects, although there is plenty of those too. So we have here Millstone Hill Observatory, Super Dawn radars, magnetometers, Big Bear Solar Observatory, Extended Owens Valley Solar Array. All these projects, all these instruments have contributed significantly to this effort. And here's a list of agronomy awards that also contributed to this effort. I'm just going to leave it for a second for you to read through maybe some titles and institutions. We cannot talk about proposals without talking about funding for instrumentation in infrastructure. And here there are 3 major solicitations that are, well, somewhat current, especially the first one called MRI, Major Research Instrumentation. So this is an annual solicitation, and it has a window, a submission window, and in 2024 it will be between October 15th and November 15th. So these are proposals up to $4 million. The next one is mid-scale level 1, up to $20 million. And this solicitation, together with its sister solicitation down low, it's a biennial thing. It's a biennial, so last time solicitation, as you can see, was dated 22, so we expect a new solicitation to come up sometime later this year with a deadline later, probably 2025. The same goes for mid-scale 2. So it's a biennial solicitation, and the next solicitation will be published in 2025. So they started kind of simultaneously, now they're a bit staggered. So something to think about. And finally, in this part of the presentation, I want to draw your attention to another very prestigious solicitation, a standing program from NSF called Career. And Shika has pulled out some nice statistics here. Turns out, Geospace has awarded over $20 million over the last 10 years to 35 assistant professors across all Geospace disciplines. And for 2024 recipients are listed here. Again, it's not just around me, there is one recipient from this community, Stephen Kepler. So to finish this part of the update, please join me in congratulating this year's recipients. So here is my update on Geospace facilities. It's going to be quick. So I want to expand on this. What does it mean that Geospace facilities has been moved from Geospace cluster to the newly formed infrastructure cluster? Well, you can see the list. Its visibility will increase internally for sure. The program will expand and further diversify to include projects like SuperMag, SuperDARN, Simpson-Newton Monitor Network. And if you think you see the pattern, you're wrong. Having super on network is not a requirement for joining the facilities. The program budget will, I wish I can tell you, but I cannot. But let's just say I'm not resigning in protest. And of course, as we said, the synergies between the Geospace Facilities Program and Geospace core science programs will continue and maybe will improve, and that, of course, includes aeronomy and CEDAR programs. And one thing to have in mind here is that facilities and infrastructure are considered to be a focus area for NSF, and it's mine and your task to try to leverage that. So let me quickly go through updates on 3 specific parts of the portfolio. The first project here is Millstone Hill Observatory. Over the last few years, we've been able to invest significant additional amount into refurbishment of the steerable 46-meter dish. And the challenge was to complete, in particular, foundation work before the eclipse, and I'm happy to report that that has been very successful. You can see some picture before and after and during. And the MIT have been able to actually collect some very nice data from the eclipse. And the team will be working on a plan for further improvement to this facility in the future. The next facility is Resolute Bay Observatory, which is part of a MISR, Advanced Model Incoherent Scatter Radar Facility. And some of you know that in September 22, a fire occurred at the facility. No one was hurt, but unfortunately, the operations and control center and the house power generators have been damaged, have been completely destroyed, in fact. As a result, RISE has stopped operating. The PI institution, SRI International, in consultation with NSF, has developed a 3-phase fire recovery plan. And I'm pleased to report that phase 1 has been complete. And that the radar instrumentation actually survived the deep freeze really well. We didn't really lose any power, any radar power, due to the radar being in deep freeze for a long time, basically for several months. So currently, RISE-N operates on a campaign basis. The next phase would involve restoration of the house generating power capacity on a permanent basis, and phase 3 will include, hopefully, restoration of capability to host guest instrumentation at the observatory. As many of you also know that we held our second competition for distributed arrays of small instruments, DAISY, just a few weeks. It was aimed at all Geospace disciplines, not just aeronomy, and we received a very good, robust community response to this solicitation. The review of the proposals is ongoing. So I thought it would be a good time for me to talk about do's and don'ts now that I have seen enough proposals that are facility or facility related. one thing to notice right away is that we have said in the past that letters of collaborations are permitted but discouraged. Letters of support are not really permitted. So the relevant quote from PubPG is given here. While letters of collaborations are permitted, unless required by specific program solicitation, letters of support should not be submitted, as they are not a standard component of an NSF proposal. The second point here should be fairly obvious, but somehow, I guess, not quite. I really cannot emphasize it strong enough. Please read the entire solicitation. If you don't, you're gonna possibly miss some critical information to do with maybe required section or any other specific solicitation-specific criteria. Another point is that you might think that when you submit a proposal that was previously declined from another agency, may be a good idea. It's not a showstopper, but it's very evident. For facility proposals specifically, it's important to maintain this balance between the technical and the science parts. And what is the right balance? Well, it's a matter of debate, but maybe you can start with 30-70%, 30 being science, technical being 70% being technical, 30% being science. It certainly doesn't hurt at all. In fact, proposals are reviewed really well if you formulate specific science questions in this science part. And then for facility proposals as well, we want you to demonstrate extensive community use. So it has to be community facility, not just a PI-led project. And then the very last point here is that we would really like you to think about your reviewers, maybe not as babies, but someone who has a lot going in their lives. They may lose focus very quickly, and they can get cranky if you don't meet their needs. So think about writing for general science readers, especially for proposals like mid-scales. That's all I have. Thank you.
I think we have time for a quick question. Once, all right. Well, you're around all week as well, right? So, yeah. You can find
yes,
Roman.
well, through Thursday, yes.
Till Thursday, yes.
Yeah.
You have it until Thursday.
And we are keeping Shika's office hours on Thursday. I'll be there.
Excellent. Okay, cool. Thank you very much. Yep. Oh, are we clapping? Yeah. And then we're going to move on to the second half of the NSF update from Tyan Wang. Is she? Oh, there she is. Yay! All right, good. The instructions for that are on there.
Instructions on there, okay. Good morning. All right, so I presented yesterday, but anyway, so for those of you who don't know me, I'm Tyan Hua. I'm the program director for the data infrastructures, also helping out with the Around Me program. And let me see instructions. So next slide. Is that, wait, this. Okay, good. So I will start by saying that, as many of you know that the Office of Science and Technology Policy, they published a memo in 2022 that requires all the federal, sponsored research has to be public assets and open, for open science. So, so I think they mandate that it has to be immediate, open, and equitable access to the federal funded research. So in response to that mandate, NSF has been working on policy updates. So they published the Public Access 2.0 that was published 2023 February. And so, the PAT, we call it PAT 2. So the PAT 2, intends to implement new federal-wide regulations for immediate open access, public access actually, there's a difference between open and public. But for NSF policy requirements, public access to articles and also underlying data for federal funding research. So as you can see the timeline here, so we are now into the fall 2024, and the policy updates of Public Access 2.0 has been published and is in the is going to be implemented, and we updated the PAPG. So you're going to see the changes in 2025. It will go into effect, and so during this process, to satisfy the mandates, there are actually two phases. We are doing the phase 1, and the phase 2, we're actually going to start in fall 2024, and the focus will be on the security, the research, the security and integrity. Okay, and that'll be 2026. So you don't have to worry about that just yet. So, so some of you might wonder, so what is the difference between the current policy and also the future policy, which was going to take effect in 2025? So if you look at the two tables, the table here, so is that on the left? Yes, on the left. On the left, that's the current policy, and the middle one is actually the policy you're going to see in 2025 January. And the blue text, indicate the difference. So, so we can see that when you compare those two, they are very similar. So the only thing that you need to pay attention to is that now, in addition to the publications, the conference proceedings also needs to be public access, and also the data that's supporting the publications. Now, regarding the let me see, how the data. Regarding the data, we are not requiring you to upload your data to the NSF PAS system. Instead, what you're going to do is that you have to deposit your data to an outside repository, and then include and then have a DOI, and then include the DOI in the NSF PAS system. So as you can see, if you compare this current policy and the future policy, you'll see that there's really not much difference. Just one step further, which is that should be easy for the PIs to comply with. Now, in addition to that, I do also want to draw your attention to NSF policy, because when you have a publication, you do not necessarily have to publish with the open journal. What per NSF requirement, what you only need to upload to the NSF part is either the publications or the author the author's accepted manuscript, which before the publication through the journals, you'll receive author accepted manuscript. You can just upload that file to the NSF part system, and that will satisfy NSF public access policy. Okay, so now I'm coming down to the geospace and infrastructures, what we have done. So I'd like to report out that we issued a Dear Colleague letter, innovation in open science planning workshops. That Dear Colleague letter is to encourage the community to submit a conference proposal to discuss the needs and also challenges, and to provide a gap analysis about the open science, what you need to do, or what resources are required. So we did that, and also we created in the agency Heliophysics Data Working Group with the members from NSF, NASA, NOAA, and also ONR. And under this umbrella, under this working group, so we have developed, not developed, but we organized a cloud workshop that was held in July 2023, and we also held 2 lesson sessions, inviting community stakeholders to come and share their challenges and recommendations with us. That was, there were 2 sessions, so July and October 2023. And just earlier this year at the test town hall, we held agency town hall, and we got a lot of good feedback. So that was encouraging. And also I serve as as a member of the NSF Public Access and Open Science working group involved in policy changes. So I'm also as the director's rep. So your voice, if I hear any feedback from you, I will make sure that our voice will be heard on the NSF level. And also, let's see. I also, the Geospace data infrastructures also, provided funding to workshops in the summer school, for example, Dash meeting that was held 2023. And also the Python and Heliophysics Summer School that was just happening in May this year, and also NCAR, NSF NCAR, they have a workshop, Community Expectations for Geospace Data Commons, that was also held in May. So May was, very busy. And just last week, we had the CCMC workshop. So all this, we're just trying to provide a venue from different, and then pulling all the information, feedback from the community, so that would better inform us, what kind of resources, that are needed in order to strategically plan the next step. And then I will also mention that within the AGS, the Division of Atmospheric and Geospace Sciences, there's there are quite a few data infrastructures that are being supported, by the division. For example, Magical Database that we all know, and also SuperMag, and also CCMC, and also SuperDawn and NPR. All these are actually part of our portfolio. So, yeah. In addition to that, NCAR, the U.S. National Center for Atmospheric Research, is also under within the AGS portfolio as well. We have oversight, of NCAR. So, NCAR, they provide different levels of services. So, depending on your discipline and the requirements, so I'm just listed a few. So, you definitely need to check out their website, to decide which one that you want to use, should you decide to use their service. So there's Geospace data, let me see, the Geoscience Data Exchange, and also Computational CISO, Information System Lab, and also High Altitude Observatory, and also Climate Data Gateway. All this, providing different levels of services. It does, some of them does come, at a fee. So, I would encourage you to reach out to Douglas Schulers for more information if you're interested. And also, they have also NCAR. They have a lot of data, a lot of data. So, if you want to use the data, go to their website and check out, what they can offer. In addition to that, at the conference, at the NCAR conference, they actually create a mailing list. So if you're interested to be, to keep updated about all the funding opportunities, all the informations about open science, public access, and data, data comments, reach out to Doug, and then I'll ask him to that you want to be added to the mailing list. And with the, so this will be my last slide. So I just want to show this. At NSF, we know that requiring PIs to be for them to be to do something in open science, make their the research output to be publicly accessible is challenging and daunting as well. But that's something that we have to do, as a PI. So here shows I list a couple of funding opportunities. So and then different funding opportunities catering different they have a different focus area. So I definitely encourage you to either to be on the mailing list, which I will definitely use that to send any any new funding opportunities so that you'll get updated. And all this not some of those are actually NSF-wide or division-wide and may not be led by the Geo directorate, but because having the public access, this is the foundation's goal. So a lot of the directorate is actually cross boundaries, cross directories efforts. So most likely if you are interested in submitting to one of the funding opportunities, we will be reached because we'll be asked to provide some funding or to provide some code review, that kind of thing. So I think it will be best that if you're thinking about submitting a proposal to any of this open science funding opportunities, and the list is going to be more, rest assured, because we're still in the phase of developing more opportunities. Definitely talk to me because I don't because I will be the if your proposal involves geospace, then definitely reach out to me because then I wouldn't be shocked that I'll be asked to co-review or co-fund, and then when something that is not really aligned, is not, maybe something that can be postponed or not at the urgency. All right, with that, I will stop here.
Okay. Well, thank you very much. Any quick questions as our speaker runs away? No. No? Okay, cool, thank you. Up next, we have Joe Westlake, and one thing we realized yesterday is that there's no clocks up here, so people don't know how long they're running. So I'm going to trust my cell phone with you.
All right, good.
And set a timer.
No, there is no clocks. You're right.
Yeah, it's kind of like Vegas.
0 clocks.
Yeah.
Excellent, excellent. Hey, so thank you so much, and thank you to the NSF, the CEDAR, for giving me the opportunity to address you all, give you guys an update as to what we're doing in NASA heliophysics. My name is Joe Westlake. I'm the director of heliophysics. This is my team. So me as director, Peg Luce is my deputy division director. I hope you guys have the opportunity when you're out in the world to thank Peg Luce for her continued service to heliophysics, but also to thank her for stepping in the second time as division director and really shepherding and keeping our heliophysics science moving forward. Nikki Rail is our Associate Director for Flight, and we've welcomed Teresa Moreto-Jorgensen, who's here in the audience, as our Director of Research. I also note that, yeah, there you go, woo! I'll also note if you guys have questions for us regarding our ROSES program, regarding proposals and other things, there is a program officer program office hour on Wednesday from 5 to 6. So please, come and bring all of your difficult questions for Teresa and Patrick, and I'm sure they'll be able to answer them. So a huge part of this year was the total solar eclipse, one of our biggest engagement activities from NASA heliophysics. We had 3 live NASA broadcasts that brought forward more than 36 million views. We had more than 1.5 million concurrent views at the time of the eclipse on our major streams. Over 36,000 individual citizen scientists contributed over 60,000 data submissions, which is a wonderful, wonderful set of numbers across many, many states. And we got a preview of that at the test. I thought that was a really wonderful session. Science activation reached over 2,000 educators across the country. And you can see a couple of wonderful shots, students out at the Cotton Bowl there, and folks at the Indy 500 having a wonderful day. I hope you guys all had the opportunity to see a wonderful celestial event and didn't get any clouds. And if you did get clouds, I hear there's more eclipses coming up. I'd like to also point out that we've had a lot of activity from the sun in the last couple of weeks, pointing out this solar storm that I think we're going to hear a little bit more about this week. Folks are presenting some early observations, whether it be talking about this Mother's Day or Gannon storm. Some observations from the SDO, some of the aurora, which I hear was amazing, though it was cloudy in the DC area, and we had to miss it, and then the series of CMEs that really lumped together and created a fantastic auroral display and some fantastic, hopefully, data that we can play with and look at over the next decades. If it's like the Halloween storm, the 2003 Halloween storm, I'm sure we'll be chewing on this for a while. Our decadal survey is coming soon. I love this word cloud that was put together by James Mason that really pulls together a lot of the information that came in from the white papers. I'll note that there's some significant parts to this community that are in that word cloud if you look carefully. Ionosphere, various other things that are there. I think I can't quite see from here, but there's a lot in there. Maybe it's radio. I see other things that I think are very relevant to you folks. This is coming soon. We expect it to drop late in the summer, and I hear we're going to hear an update on that and are very excited to see the results from this decadal survey and to see the things that are going to push us forward into the next decade. This is our heliophysics fleet chart. The way to sort of read this is that the missions that are in green are in their prime operations: Solar Orbiter, Parker Solar Probe. And the missions that are in blue are in extended operations, and the missions in yellow are in development. Let me give you a little bit of a better feeling for the things that are coming up soon, but I will note a couple of key changes to this as well. We have said to some degree goodbye to the AIM and the ICON mission in this chart, which little tear comes to the eye, and I think is really a huge kudos to those teams for their continued support and effort moving forward. And really just, I don't know if you guys, maybe a round of applause for those folks. I think it's been a big labor of love. I requested that we put those on this chart with maybe some wings on the side, but was told that's unusual. Coming up, we have a large number of launches, many of which are of interest to the folks in the room here. Escapade, our first heliophysics mission to Mars, launching on a Blue Origin spacecraft in October 24. EASY, I think Sam is out there somewhere. There he is. EASY and the EASY team, hopefully launching late this year. Sunrise launching early in the next year. Tracers, Punch, IMAP, and Carruthers. IMAP and Carruthers launching together early in the next year. So it's going to be a very busy time for heliophysics, and really excited for the new data as it comes down. Give you guys a couple of mission highlights. So we heard a little bit yesterday about some of the results that are coming down from the atmospheric waves experiment. Really excited to see the gravity waves work at the edge of space, and to see the multitude of data, large quantities of data coming down from this mission. There's a presentation on Friday at 8:35, so early in the morning. I hope folks will show up to have a look at some of those early results from AWE. EASY, we talked about a little bit. So there's a presentation from Sam coming forward on Friday at 8:50 on EASY. EASY, of course, is looking at, it's a set of three 6U CubeSats looking at the auroral electrojets using a really fantastic application of Zeeman splitting. Really excited to see this mission go forward and the technology that it brings forward with it. EASY is in phase D. And I'd also like to send kudos to the folks that are working on the education and outreach program there. Some really wonderful activities over the last couple of months, including one with the Navajo Nation that I thought was really a wonderful application, and are really pushing out and going to people where they are. I would like to encourage you all to share your science with us at NASA headquarters. We'd like to be able to take the work that you're doing and show it off, and be able to show our stakeholders really the amazing work that's going on within the CEDAR community. There's an email here at the bottom that you are welcome to send science nuggets, just one slide, quick updates on what you're doing. And we'd love to be able to share those, to be able to report to folks, the amazing science that this group is doing, the amazing science that we are doing in heliophysics, really to show and prove forward. The proof is in the pudding that we can really do great stuff here in heliophysics. These are very simple, so here's an example of a straightforward science nugget that we can use and put as a part of some of our briefings. So this is a straightforward science nugget that reports on a scientific paper. The paper is linked. This talks about solar moss from the IRIS and the High C mission that was looking at some of these small scale structures on the sun. Yours can be as easy as this. Send it to our email address, and we would love to be able to show off the great work that you're doing. Let me give you a couple of programmatic updates. So our RNA update, you can see we've selected at HSR, HGIO, HFOS, HTIDES, and LWS. It's easy to say those one after another right away. It rolls right off the tongue. A significant number of proposals were selected. I will note that we've gotten a significant uptick in our proposal pressure, so you all are writing lots of proposals. I think that's wonderful. I'm interested to hear exactly why our uptick is significant this year. So if you guys have ideas and thoughts as to why more proposals are going in, and I know there's probably some straightforward speculation and answers, I'd love to hear it, and our folks at headquarters would love to hear about it as well. We are working to get our selection rates in a good place. These selection rates are relatively low, and we'd love to be able to put more behind our research. We're looking to maintain this robust RNA program through the solicitation of our ROSES 24 and 25 elements as well. We've also stood up the Heliophysics Strategic Technology Office, the HESTO. This allows us to put forward technology and to really create a collaborative area for for technology across the nation within heliophysics. There is a technology symposium. I encourage folks who are interested in heliophysics technology or who are participating to come and join us out at Wallops, September 18th and 19th at the Wallops Flight Facility. There's a website there, hesto.smce.nasa.gov. Please go out and check out all the great work that's going on across heliophysics and technology. I'd also like to send kudos to the NASA Sounding Rockets program. So a significant number of folks in the audience here. Let's see, I'm looking out, right? Yeah, so many folks have been a part of our Sounding Rockets program. The current motor inventory is healthy. In fiscal 23, we had 11 missions launched, 2 Norway campaigns, the ACES and Vortex, so really wonderful activities there. Fiscal 24, we had 21 missions total. Huge kudos, 11 missions launched, 10 missions are remaining. The 2 APEP CLIPS campaigns with 6 total missions from White Sands and Wallops. I know Aro is probably out there. Kudos to him and his team up here on the image as well. And then in fiscal 25, we have 15 missions total on the manifest, 4 campaign deployments, Norway, Poker, and Kwajalein. And then we're starting on some of these Peru site improvements. There's a discussion a little bit later on about the Peru campaign and other things that I think is going on here at this CEDAR workshop, and I look forward to seeing some of the science that's going to come from that activity. Our upcoming summer launches, Herschel 3, Rock On, Magix 2, and FIRST, set to launch through June, July, and August. Really looking forward to the continued work within the Sounding Rockets program. I'd like to announce that we've selected a program office for our space weather program. As you guys know, we've been building our space weather program within NASA Heliophysics. We've brought on NASA Langley to participate as our program office. And this new space weather program office, I think, will help us execute the national needs in space weather, and we look forward to working with the folks at Langley on this. Our heliophysics big year keeps getting bigger and bigger. There's so many citizen science projects. I'd like to encourage you all to take this heliophysics big year into solar maximum, into some of these solar storms and other things that are going forward. Engage and be a part of those communications. We've had more than 36,000 volunteers in Eclipse in the citizen science world. Terabytes of data have come in as a part of that. And a lot of these continued observation campaigns and solar maximum substorms have really made an impact from heliophysics world. Really excited about this and really excited about the citizen science work that's going on. Let me give you guys a little bit of an update about our heliophysics budget, mostly focused on fiscal year 25. So within fiscal year 25, our main priorities for NASA Heliophysics was to maintain a balanced mission portfolio that ensures the success of the missions that are currently in development, stewarding the Heliophysics System Observatory. As you know, we have a multitude of missions that are in operation, and enabling future missions to the extent possible. We nurture a vibrant and inclusive RNA program. We're supporting partnerships with our international space agencies, whether it be EUVST with JAXA, COSI that's going on with the Koreans, and various other international partnerships that we've been working on. We support the national priorities in space weather, orbital debris, and space situational awareness. And you see there on the right one of our missions that's getting ready to get buttoned up and hopefully launched early in the next year, so that's the IMAP mission. This advances Escapade, Easy, Sunrise, Tracers, Punch, Carruthers, and IMAP towards launch late this year and early next year. This supports a healthy cadence of PI-led Explorer missions, Muse and Helioswarm, of which are the next on the docket. And we're expecting to have final SMEC selections early in 2025 or sometime in 2025. Future Explorer solicitations in fiscal 25 for the MidX and fiscal 28 for the SMECs. Now, this also proposes in the fiscal year 25 President's budget cancellation of GDC rather than a 3-year pause in recognition of out-year budget constraints. However, that is not all of the story, and I'd like to talk a little bit about GDC and Dynamic together. So GDC and Dynamic are currently in a pause state. GDC specifically is in a pause state given the fiscal 23 and 24 budgets. The fiscal 25 President's budget as a budgetary request and as a proposal, proposes canceling these missions. These missions together, we believe, will build the science that is needed and desperately asked for by this community, and we believe that there is still potential life in these missions moving forward. And I hope that we have the opportunity, and I've seen it in the last couple of days here. I've seen, the interest and engagement and encouragement from the community in these missions. So really looking forward to hopefully being able to push these forward. But as we said, we do have budgetary constraints in the out years. I want to thank the CEDAR community. I got a very wonderful letter stating support for these missions. I hope that you share that more broadly than with just me. And I want to point out, really the GDC and dynamic missions close large scientific gaps in the knowledge that we have about the upper atmosphere, about the transition region, about some of these areas that are very important for our heliophysics science. Whether it be GDC looking at the energy from above, dynamic, which is looking at the energy from below, really looking at that region where the rubber meets the road, where our space weather meets terrestrial weather. I'll note that the dynamic AO is out there, and that selections are expected, let's just say imminently. They're happening very, very quickly, and we hope to have some news on that very soon. Okay, please get involved, stay informed, submit science highlights to our HQ Helio highlights at hq.nasa.gov. And also look out, there is a community town hall on the 18th of June, virtual, that you guys can dial into. You can submit questions. If you follow this link, you'll be able to submit questions into our IO tool and be a part of that conversation. I welcome any questions, and I think I actually got this done ahead of time, so we can actually take a minute and take some questions, and I'd love to have them.
Cool. Thank you very much. Any questions?
Only hard questions.
I think Rob Pfaff was first, and then I saw a hand over here, and yeah.
Hello. First of all, I want to thank you for coming. I think it's so important. And my question is about GDC. I think it's so incumbent on all of us to maintain sort of the fight, and that GDC science is so important. We know you have budget issues, and it's so important that we don't roll over. I guess my question is really, what can we do besides just be positive? And before you answer, I must say that the one aspect of all of this that is hard to talk about is that the ITM community seems to have had a history of stumbling or whatever over the many years. We've had missions not go forward compared to, say, solar or magnetosphere or something. I don't know whether we're too ambitious or not focused or what, but if you had any comments on that, I would appreciate it.
Yeah, so GDC specifically, it's a very focused mission concept. I'll note that the mission teams, the instrument teams have put together something that doesn't have a ton of fat on the bone, right? So some of the things that folks usually talk about in these, let's come up with different scenarios, let's come up with other ideas. I think for GDC specifically, it's just continue the support, continue pushing forward. Know that there's a significant number of NASA missions that have gone forward after having been zeroed out in the president's budget. That happens, right? Know that there is light at the end of this tunnel, and know that, and I would encourage this community to be supportive of your colleagues that are a part of that mission. That is a place where we as a heliophysics community, as we move forward and speak with one voice, we become stronger together. So having a unified heliophysics community that understands that GDC is the next priority for us to work against in Living with a Star in our strategic programs, and that is all advocating for and being a part of that mission, is very important. Yeah, I hope that helps.
Hi. Could you comment on CubeSat missions or calls for CubeSat missions coming up? I heard there was supposed to be an H-Fork call at some point this year, and I didn't see anything about that, so I just wanted to get a better understanding.
Yep. Yeah. So I mean, our CubeSats, for the most part, We've augmented some of the funding for CubeSats as well, and H-Fort, thank you, is coming soon. Absolutely.
Thank you. So I wonder if you can share your thoughts and your view to what extent GDC and dynamic are actually missions that are really tied to each other, or not necessarily limited to flying one or the other mission, but also in terms of a timeline, for example.
Yeah, I will note that the announcement of opportunity for dynamic assumes a GDC in existence, so that AO has that built into it. I'll say that the importance of having those two missions operating together, I think is together is better than either mission singularly, and so I hope that we're able to do those two missions together in that regard.
And, oh, we have two more questions. I did see Ruth's hand. Yeah, we'll go Katie and then Ruth, and then we should probably move on.
I hope this is a quick question. So you mentioned that there was increased proposal pressure. Do you have any numbers you can share with us on that?
I would encourage you probably to chat with Patrick and Teresa. The increased proposal pressure that we've seen in HGIO and HSR in the last couple of months has been intense. The number of proposals that have come in were totally unexpected, and to some degree is just more than we anticipated. Hundreds of proposals. And you guys will probably see in the coming weeks to months a broad call for support in reviewing these proposals. We're hoping to bring back some of the in-person proposal reviews. As you guys know, as a part of proposing these many great scientific research objectives, it takes a lot of work to actually review these things, and it takes a lot of community support to make that happen. On top of the increased proposal pressure, we've seen a decrease in interest in participating in our panels. And so we would love it if you guys raised your hands and helped us out in that regard. And also I will note, I don't know, I'm going to single out my headquarters colleagues that are here. Maybe raise your hand real quick. There's a significant number of headquarters folks here in the room. Oh, thank you. Yeah. Folks are around this week. We don't bite hard. Take a minute and come chat and ask us some of these detailed questions. We'd love to hear them, and we'd love to hear feedback about how things are going.
Last question from Ruth. Oh, behind you.
Thank you. Regarding the proposal pressure, you were curious what could possibly be leading to this flood. And, might I suggest that placing timed and gold into maintenance, into infrastructure mode is one possibility, because the only avenue for these folks that were associated for those science teams, the only way for them to keep doing science is to propose to places like HGI and stuff like that. So.
Yeah, Ruth, that's a really good comment.
2 cents.
We're moving, as you guys have heard and have seen from folks, we're moving the Heliophysics System Observatory into a different mode. So from the results that came out of the senior review, many of the missions have been pulled into a different mode. We got a lot of feedback about the usage of the word infrastructure. Our NSF colleagues, that takes on a different meaning depending on where you go in different places. The attempt is to open up the ability for us to do system level science and to do proposed science against timed, against various other missions in that regard. And so that's good feedback, and I really appreciate it.
Success rate of HSR was the lowest among all those ROSES programs. It had a 14% selection rate compared to like 23% for the others. So it's the whole situation strikes me as being very, very difficult.
Sure.
For these former science teams.
Appreciate it. Thank you.
All right, we To move along, thank you very much.
Thank you so much.
And up next, we have Sue Feng with a NOAA update.
Thank you. So thanks for the opportunity for me to be here to talk about what we're doing in NOAA. I think people are less familiar with what we do. NOAA is a pretty big agency. We have about 12,000 civilian and federal employees. On top of that, we have almost double up of the contractors and university employees. So why I show this is a very complicated chart, and sometimes I don't even know where I belong to. But three things I want you to learn here today and remember how that works is there are three offices that are relevant to us. One is Office of Space Commerce, really under NOAA. Office of Space Commerce under the Space Policy Director 3 has been directly instructed to transition all the space domain awareness and space traffic coordination from DoD to NOAA to support all the commercial entities. So NOAA will be the one that tracking all the space collision problems, conjunction analysis, and everything like that. So we work closely with Office of Space Commerce to help them with space weather environment. And my office actually Space Weather Prediction Center, SWPC, we call SWPC. SWPC is actually under National Weather Service. Our job is really monitoring space weather environment and provide alert, warning alert, and all kind of information to the nation. And the other office called SWAL, which is under NIST's Space Weather Office, which is collaborating directly with NASA to look out for the future architecture for space weather observations. So I'm going to present SWAL slides for Al-Said to start with. So Al-Said, Talad, and Irfan Azim are leading the Space Weather Office that providing all the space weather data that SWPC needs to do our services. So SWAL is responsible for formulating all the NOAA space-based architectures and missions and maintain all the ground segments and space segments to make sure we have all the data that we can use. So it's a joint NOAA-NASA office that we have all branches and people in different sites. And there are currently two programs. One is Space Weather Follow-On, which is trying to maintain our capability at L1 point. Without that vintage point, we will not know space weather is coming. So the first program is Space Weather. The GOES-U is going to be launched next month. Is the last series of GOES series that carried space weather instruments. It's going to be launched next month, next 2 weeks by SpaceX Falcon Heavy spacecraft rocket next week, 2 weeks from now. We're actually going down to Cape. And then the other program is Space Weather Follow-On, Space Weather L1 mission. That mission particularly will be launched next year to continue support our L1 capabilities. And then SWFO coordination is working with NASA IMAP directly. And the other one is Space Weather Next program. And I did tell Al-Said they need to change the name because I can't even pronounce it very well. Like everything is Space Weather program, but I think there must be a cooler name for that. But depends on how we do it. There is a lot of mission we need to support, including L1, and working with ESA on L5 mission, promoting geo architectures, HEO architectures, especially for the Aura imagers. And we're trying to look into how to do LEO missions. And we do want to do the LEO as a host payload opportunity in the future. So continue maintain all the capability in the space to make sure we all can serve the nation. And then right now, I think SWAL office focus on the geo architectures. We are making sure we can detect energetic particles, have the magnetometers on all the spacecraft, and making sure there are several space weather-related measurements can be provided. And again, we are looking into the thermosphere imagers so that we can continue provide gold-like instrument in the future. So there are a lot of study carried out and trying to refine some of the requirements, and you should probably hear more in the coming year. And then we actually don't have a research program. We don't give out grants, but there are a few projects that we're really interested in doing. Then we actually go out and work with research and bring them to work with us directly. So there's a joint venture program. It's basically working with the industry to enhance that capability that we need at NOAA. We also have, NOAA actually, I didn't mention that today, we have a very strong commercial data buy program that we do buy ionosphere RO data. We do look into how to utilize those commercial data to enhance our capability. So there are a few projects that I highlighted here. So one is we work with Eric Sutton on Starlink data. So I will talk a little bit more on that. So we have been working with Starlink over a year and two as SWPC, and over past year, we are started looking into how to use their ephemeris data to back derive the neutral density. I'm sure Eric might be talking about that a little bit more. And we are building some of the solar cell fabrication to see if we can go closer to the sun, right? We've got to be able to move around, not just stay in that L1 point. And there is a Triton development through NRL through Bruce is here today, so he will be talking about that maybe a little bit next talk. And there are other three or four projects currently funded in FY24 to support research operation internally for NOAA. And we also have very strong SBIR program for the commercial sectors to bring in space weather domain awareness. And then where I am sitting is actually Space Weather Prediction Center. I have a very strong team behind us. And at SWPC, we have about research session, about 30 PhDs actually maintaining the research to operational flow, working with NASA and other agencies, NSF and DoD closely. So in my team, what we do, we're actually the front line of space weather. So when you guys watching Aurora, we are all scratching our hair trying to figure out what's going on, right? So we need to figure out what's going on next hour. We also work with our core partners in both government and industry very closely, go through the event. So in my team, what I take care of is really the HF comms. So we need to work with FEMA. We work with Collins Aerospace, which is the HF communication center, East and West Coast for all the international flights. We work with airlines and trying to make sure their mission is not being interrupted when flare happens, when proton event happens. So we have strict restrictions on getting ICAO support for the aviation system. And we have to maintain all the product that you see right out there to make sure we mitigate all the storm impact. So if we do a good job, you will not hear anything. So which is very sad for us because we'll never be able to compete with hurricane. We'll never be able to compete with a lot of property loss with other weather events. But we are trying our best to do. And we're also trying to use INOSON data and trying to see how we can maintain that ground-based infrastructure for us and for the community as well in the future. And we also have a very strong correlation with the satellite PNT and SATCOMs. So we work directly with the GNSS manufacturers. We work with FAA. We work with PNT services. You know, there are a lot of spacecraft that are currently emitting PNT signals right now, working with GPS receiver companies. We also work with space industry on trying to fulfill their needs on PNT and SATCOM. So at SWPC, we have a few products, and you will start to see very soon, we're going to have the GlowTech in public available in a month about time. And then within that data simulation system, we ingest Cosmic 2 missions as well as all the ground-based data in real time. And we are also considering putting into commercial data, and we are working with Google on Google phone signals to put it into that. And just imagine how much signal we're gonna go getting that. So think big, right? So once you have millions of signals in that plot, what are you gonna get? I started seeing plasma bubble in some of those signals. So the other thing is we also have ROTI in real time right now. It's 1 Hz data trying to capture some of those variability of the simulation that we are seeing in our system. And we are also going to release the S4 and Sigma 5 provided with 1 Hz data from ground-based receivers, actually working closely with Boston College on tackling some of these technical problems. And then space industry, right? So because we started to worry about neutral density in space industry, we had a test bed engagement. We brought in a lot of customers and partners last year to work on the problems for 3 days. And we got all the prime space companies to join us and to really talk about how we mitigate these mega constellations problems and what are they looking for. So my team also take care of the neutral density environments. Right now we have this WAM, so I'm trying to see if I can play that animation. So this is the May storm from WAM model. So you can see that the density enhancement, you're still seeing very, very strong neutral wind at 400 kilometer, 500 kilometer. We're looking at kilometer per second wind. And how does that interact with satellites, and how does that increase the drag they're experiencing, something we're working together with them. We have real-time product that at the bottom side kind of showing how much percentage change and density change during the storms, and I know they're watching it because I did get called all the time when storm happened in the middle of the night. So people are using our product, people are using your research to enhance our capabilities. And we have several Nessus-funded projects. One is Cosmic 2, one is Starlink project. What we're trying to do is using those missions to back-derive neutral density orbit average densities, and using that to bias correct or data assimilate into our model to have a better baselines and also improve our predictions. So we've been working extensively on some of those projects, and hopefully you guys can get benefit in the future to understand that environment better. And we also have an office space commerce funded mission. PI is Piyush Mehta here. He is going to work, in that particular project, we work with partners from the industry directly to understand how we can do the probability forecast of neutral density environment, and how can they use that probability forecast along with machine learning algorithm to put it into their orbit propagation tools. So I think there are a lot of exciting things going on. This is my last slide. So I want to make sure that you guys are aware of what we're doing. We're trying very hard, working with the partners, to make sure we're safeguarding the properties and lives of the nations. Thank you. If you want to talk to me, I'll be here a whole week and really understand how the research program works and how we do the research operation. Thank you.
Do we have any quick questions? Very quick. Going once, going twice? Okay, we go around, so awesome. Thank you very much. Up next, we have Bruce Fritz giving an ONR update, and I'm going to restart the clock. Cool. So, reset, and go.
Hi, good morning. My name is Bruce Fritz. I'm here representing the Office of Naval Research team. Our group is headed by Dan Eleuterio. We also work with Josh Kossuth, who is kind of our expert on satellite remote sensing, and Catherine Mulroney, who helps us a lot with our transition to operations. And I'm primarily helping the team as a kind of a bridge to the scientific community, the CEDAR community. That's why I'm here today. So I just learned about an interesting bit of history this past few months that I thought was worth sharing in my very, very limited time this morning, just as a bridge to why ONR is involved here. As it turns out, CEDAR was proposed, or not CEDAR, NSF was proposed by Congress back in the late 1940s, and President Truman actually initially vetoed it. So that got put on hold for a couple of years while they tried to figure out how to establish this government organization to fund U.S. scientists at universities through grants. And actually ONR stepped in those intervening couple of years to kind of fill that void. And so, depending what historian you talk to, some will say that NSF was largely based on the model first established by ONR. And so the degree to which that is true, I'm sure your mileage may vary, but we do have a very closely intertwined origin story. And of course, we've gone our own separate ways over the years, but we do have a very strong investment still in very basic science, where we do invest in university professionals through grants to just do, what we call use-inspired basic research. And so here, we've got a fairly wide range of interests in the space-weathered realm and space science research, but really, because we're a relatively small program, especially compared to NSF and NASA, we really try to focus on one specific problem set, and that's really the bottom side ionosphere. We're really worried about impacts on HF communication and radar systems, and so any sort of research that impacts that region, the D region, the E region, lower atmosphere coupling, and those sorts of problem sets are really what we're focused on. And that bottom little bubble chart there is just kind of showing our pipeline from very basic use-inspired research, similar to NSF-style grants, all the way up through our applications pipeline that like Catherine Mulroney helps us transition things like our own operational model into operations. So I've only got a few minutes, so I really want to focus on the funding that we have available to the community. The first one, maybe many of you are interested about, is the MIRI that was advertised a few months ago. This is a multidisciplinary university research initiative we actually wrote in partnership with Julie Moses at AFOSR, who can't be here this week. We actually received 4 white papers about that a few weeks ago, and we have reviewed those. So those will be getting their feedback out here, I think, any day now. We had to submit our stuff yesterday, I believe, to the MIRI office. So we will be selecting just one once we get full proposals later this year. But that's hopefully a nice little injection of funding into the community that really aligns pretty well with some of the grand challenges that we've already seen this week. For some student funding opportunities, we do fund students. So if you are looking for internship opportunities to see what research is like outside of academia, there's some programs here. The NREP program is one that ONR sponsors, where you can go work with research scientists at various different naval institutions, including NRL, who we've seen many people from already this week. There's the SMART Scholarship Program, which is an even more involved program where you can get a stipend as you work, and that actually leads to employment after you graduate, so it's actually a pretty nice little deal. And there's even a high school student research opportunity program through the CEAP program. There's also an early career funding opportunity similar to what AFOSR offers, the Young Investigator Program. This can fund anyone within, I believe, the first 5 years of graduation after grad school. And so this is a very, very competitive program because we compete with the entire scope of ONR. And so that's a pretty wide swath. So the selection rate is reasonably low. It's very competitive, but we do have one in the audience here. So if you are curious as to, what John did to win his proposal, you can go pick his brain or you can come talk to me. In addition to that, we do have research infrastructure programs through DURIPS, their Defense University Research Instrumentation Program. We got one awarded a couple of years ago, I guess just about a year ago. Simon Shepard at Dartmouth was able to upgrade some of the SuperDAR network. And so this is typically an annual call. I know the most recent one is closed now, but there will be another one coming up again, probably in about 6 months. So if you're interested in an injection of funding, as high as $3 million, we can work on that as well. And we also do SBIR, so small business investments to develop technology that's related to NSF research. So there's a couple here that we've developed, including one that's a miniaturization of the MIGHTY instrument from ICON that Chris Englert is working with, and then a couple that we've done recently that are developing technology relative to UV remote sensing. And so I'm already over my 5 minutes allotted here, so I will wrap up and just say that we have all these selected programs that I just mentioned as specific targeted topics, but there's also just the general call here that I link as well. So if you have just ideas for basic research, you're welcome to come talk to me with your ideas, and we can figure out how we can maybe bring you into the ONR research community. My email's there. That's actually, well, that'll get to me. That's fine. There's the website there that can contain almost all this information that is showed on the screen here as well. And of course, I'll be here all week. So happy to take any questions if you have any.
Thank you very much. Any very brief questions? Going once, going twice. All right, cool. Thank you very much, Bruce. Up next, we have a decadal survey update from Laing. And I have to follow you and reset the clock.
Thank you. Okay, so as a member of the Decadal Survey Steering Committee, I will give a very quick update on the Decadal Survey for Solar and Space Physics, also Heliophysics, 2024-2033. So what is Decadal Survey? Decadal Survey is a 10-year strategy for research and operations for solar and space physics. It gives recommendations for NASA, NSF, and NOAA. It is mandated by Congress, and it is organized and produced by the National Academies of Science, Engineering, and Medicine. Survey organization. The survey organization, including a steering committee with 20 members and 5 panels, the Sun and the Heliosphere, Magnetosphere, Ionosphere, Thermosphere, and Mesosphere, Space Weather Science and Space Weather Science and Application, and the state of the profession. And the timeline. So the steering committee, started a meeting in August of 2022, and then the panel meetings, followed by the technical risk and the cost evaluation, the trace process for selected space missions. And so now the trace process and the panel reports and the steering committee reports have all completed. And the steering committee reports is in the hands of the national academies, and the review process is underway. So the next will be the publication and the release somewhere here in 2024, and we are currently here. So in summary, the decadal survey is near its completion, and we are targeting a pre-publication report in summer of 2024. And the next is the public release. So at time of public release, press conference with public will be held, so look out for announcement. And there will be also possible congressional hearing and briefing with the decision maker. Thanks. This time.
Any very brief questions? Cool. I feel that, yeah, there's not a lot that can be said about the decadal survey right now, but it's good to have an update to just kind of be like, it's still happening, it's still going on, so yeah. Yeah. Up next, we have a State of the Students report from Andrew Pepper and Sophie Phillips.
Good morning, everyone. This year, Sophie and I want to do something a little bit different, and we actually wanted to get up here and give you a report of some of the feedback that we received in previous years, and it's a good starting place to know where the CSSC starts planning and what things are on our agenda as we go into planning the next year. So first, I'm going to start with some of the feedback that we received from 2023, and I'm just going to kind of highlight, maybe. If you see this right here, this was the resounding feedback that we got, that students are really interested in more community engagement events and DEI, outdoor activity kind of things. This is centered on Student Day, but you can imagine that this can be translated to the conference at large as well. I'd also like to highlight that the tutorial-based topics that we have for the lightning round talks at Student Day in the first round are very popular among students as well. To go into more some of the actual feedback that we received last year, things like pronouns on the name badges, making sure that we have a science communication session, making sure that DEI is more impactful and prevalent throughout Student Day and the workshop at large, as well as this last comment. I think that one really cut me deep personally, but knowing that the conference wasn't as friendly to students should be something that all of us can strive to rectify as we move forward. But with that said, and these things that we did, we came out with a good plan. So we added pronouns to the name badges. We did have Student Day with a career panel, science communication, and interactive DEI sessions. And we had addition of the student committee. So there's 3 members out in the audience. They've really been instrumental in helping Sophie and I plan this week and provide a student activity, sometimes more than one a day, but at least one every day, Sunday through Friday of the conference. We also have the student scavenger hunt to incorporate meeting and talking between senior scientists and students. And we obviously added this, a State of the Students report that hopefully will continue on in years to come. And with that, I'm actually going to turn it over to Sophie, who's going to talk about some of the feedback that we received this year.
Thank you, thank you. All right, fast forwarding to the present. Oop, that's too much. So we send out a survey after Student Day, and so we've already received quite a bit of feedback, so thank you to all the students who filled that out. First, we'll start off with just some of the demographics. We have here on the left the sort of research demographics of the students that are present at CEDAR. A lot of modelers, GPS and satellite people in the crowd with students. But I think one of the most pressing demographic numbers that we got is on the right here is how many times have you attended CEDAR? Over half of the people who filled out our survey are first-time participants. And so it's really important that we do a good job in making students feel included from the get-go, from your very first CEDAR here, because your first time is going to influence if you even come back. So we're definitely, we recognize that. So going forward into specific comments that we've gotten from students, we got how much people enjoyed the DEI event that was incorporated into Student Day. However, some people would be interested in seeing that that would be applied to advisors and PIs as well. We've gotten comments about union organizing or tactics would be good workshops to have in the future. Students are interested in open questions in space physics as well as hardware design of instrumentation. As always, there's more breakfast feedback. We see you, we hear you. We want to do more, we're trying. Students are obviously very interested in the location. People love San Diego, love big cities. And then some positive remarks as well. Students enjoyed being recognized by the chair and by all the other students. And this last comment is a nice comment. CEDAR is as great as is, especially the support it offers for students. And I don't mean just the financial support. I really can't think of anything to make it better. So thank you for that comment. So a quick summary of student thoughts is that for a lot of students, science is obviously important. However, the reason that we love CEDAR and the reason we come to CEDAR is to build community. That isn't to mean that students aren't stressed and that students don't have many problems at our home institutions. As you can probably guess, we're underpaid, we're underinsured, we often feel unheard at our institutions. Workers' unions is also a big topic. But in terms of CEDAR, students appreciate the community that they find here. Students also are interested in more DEI conversations that are held with the community, more open conversations involving everyone. And finally, we appreciate being in a part of the sessions and acknowledged, not only being accommodated, but included and appreciated. And so with that, I think that's the end of the student thoughts. So feel free to come up to me and Andrew if you want to talk more about student involvement. But thank you.
I think we have time for a quick question. Cool. Is there anything from Slido?
Good idea.
Nope. Okay. All right. Thank you very much. The last thing we have on the morning agenda is a tribute to Jen Gannon from Romina Nikukar and Rebecca Bishop. And I'm just resetting the clock.
Good morning, everyone. Today, we would like to take a moment and remember Dr. Jen Gannon, who passed on May 2nd, 2024, leaving us much too soon. Jen Gannon was an amazing person who connected with many of us across both the CEDAR and GEM communities. She was a dear colleague, a friend, an advocate, a visionary, and an all-around Renaissance woman. In the following slides, we want to share just a few of her many accomplishments, talents, and passions. Dr. Gannon received her PhD from the University of Colorado Boulder, working on magnetospheric particle dynamics. Jen was a highly intelligent individual, but first and foremost, she was a scientist and a forward thinker. Over the course of her career, she held various positions within the government and the private sector. She was a research physicist at NOAA and the US Geological Survey. She was a principal scientist at Geospace LLC before joining Computational Physics Inc., or CPI, in 2015. At CPI, she held various positions, including Vice President for Research and Development, Chief Scientist, and Vice President of Strategy. Most recently, she joined NOAA's National Environmental Satellite Data and Information Service, or NESDIS, in the Office of Space Weather Observations as the Senior Space Weather Liaison. Jen's specialty was radiation belt physics, magnetic field observations, and geomagnetically induced currents, or GICs. Some of her publications are listed here. Jen was a principal investigator for the MagStar magnetometer network. Here we show an example, a map of the network and an example of the individual instrument. She strongly advocated for a high-density nationwide network of magnetometer as part of a strategic vision. She appreciated the importance of these measurements that are needed to understand GICs and their effects on the power grids and their subsequent impact on the society. Jen was focused on ensuring that magnetic field data is publicly available so that all aspects of our infrastructure could prepare and mitigate space weather effects. As a tribute to her many contributions, it has been proposed that the May 2024 geomagnetic superstorm to be known as a Gannon storm, as Joe Westlake also mentioned today.
So even as she grew in success scientifically, she always looked to give back to the community. Jen cared very much about the community and the future of science within our nation. Her expertise and her passion led to her being invited to participate in several important committees, discussion and review panels, as well as other leadership positions. One of those positions, or one of those times, was she was a part of the GDC Independent Review Board that took place last year. As part of her interest in GIC impacts on power grids, she advised the North American Electric Reliability Corporation, and this led her to participate in the formation of the American Commercial Space Weather Association, where she eventually served as the executive committee chair. More recently, she was appointed to the Space Weather Advisory Group, as well as the Space Weather Roundtable, as part of the implementation of the Pro-SWIFT Act. As part of SWAG, Space Weather Advisory Group, she helped design and implement the power grid sector end user survey, as well as provided invaluable input to the 2023 report on findings and recommendations for successful implementation and transforming the national space weather enterprise. Finally, she was one of the editors of the Space Weather Journal. Her final project initiative was promoting a topical collection on space weather research to operations to research pipeline, progress, challenges, and prospects. This is now open for submissions. And as a side note, submissions are welcome for those that may want to discuss some of the various contributions Dr. Gannon made to the space weather field. So Jen had a lot of other passions. She was very well-rounded, and she was equally enthusiastic in her personal life. She often shared stories about her furry four-legged family members, but she really seemed to thrive through connections with people throughout the science and commercial communities. Several people have shared their memories of Jen, where she and they often met over lunches or dinners, and this aligned with her other passion, which was food. She loved her home state of Texas's barbecue and Tex-Mex, and if you wanted to find out the best places to go in Texas, you just asked her. She was also an excellent cook, and she was classically trained in piano.
We would be remiss if we did not highlight Jen's advocacy. She was a fierce advocate for equity and a healthy scientific culture where everyone can thrive. Here we highlight an editorial piece that she first authored, focusing on advancement of diversity and inclusion in the space physics community. She convened several sessions at meetings like AGU on the topic. Also, she was a strong supporter of related AGU initiatives championed by others in the field. This is a picture she took at the mental health town hall at AGU last year. She was a caring mentor and a strong, compassionate proponent for women in the field. Unfortunately, like many women in science, she experienced discrimination and harassment. Regardless, she used her voice to support women and to promote positive change. As Bob Kerr put it best, we should continue her tireless efforts against bullying, abuse, harassment, and gender bias in the community.
Finally, as we close, we would like to leave you with a few quotes from various friends and colleagues. During the break, please feel free to reach out to Romina and I or anyone else to discuss your own memories and thoughts with us regarding Jen. We would like to thank the steering committee for allowing us to do this today, and to all the people who kindly provided us with pictures, thoughts, and perspectives on Jen. Jen's untimely passing left us with a major hole in our hearts, and we will continue on with her vision for the national and space weather enterprise and a healthy community culture. Thank you for your attention.
With that, we're going to move into our first break. Thank you very much, everyone.